Now we'll learn about integration. So integration, as you know, it is the reverse process of differentiation. So it is the reverse process of differentiation. So if ddx of fx or ddx of fx, derivative of fx, it is a differentiation of fx plus c. Then this is integration of zx. Integration of zx is fx plus p, because after taking derivative of fx, we get the value zx, and that is why we say it is the reverse process of differentiation. So to learn about integration, we must memorize some basic results of differentiation. So we see here x to the power n, integration of x to the power n is equal to x to the power n plus 1 by n plus 1, provided n is unequal to minus 1. N is unequal to minus 1 because if n is equal to minus 1, then this is 0 and it is undefined. So for n not equal to minus 1, we have this formula, and this is derivative case. So you take the derivative of x to the power n plus 1 by n plus 1, it will be 1 by n plus 1, then n plus 1 x to the power n is equal to, this will go cancelled, and it is x to the power n. Then this is from this integration of 1 by x dx is log x. This log x is derivative of log x. It is coming from this ddx of log x is 1 by x. E to the power x, integration of e to the power x is e to the power x, because ddx of e to the power x is e to the power x. Integration of a to the power x, see the difference. E and a are not same. A is a real number and e is a fixed value. E is the irrational number e, and this a is a to the power x dx. It is 1 by log of a to the base e a to the power x, because if we take the derivative of this function, we get the value a to the power x. Then integration of sin x is equal to minus cos x, because ddx of cos x is minus sin x. Integration of cos x is sin x, because ddx of sin x is cos x. Similarly, ddx of tan x, we know it is sec square x, so integration of sec square x is tan x. ddx of cot x is minus cosec square x, so integration of cosec square x is minus cot x. ddx of sec x is sec x tan x, so integration of sec x tan x is sec x. ddx of cosec x is, so like this, same. So sine inverse function, so these are inverse trigonometric functions. So ddx of sine inverse x is equal to 1 by root over 1 minus x square, and so we have integration of 1 by root over 1 minus x square dx is sine inverse x. So this formula, this we should know all this to do integration problems. So integration of 1 by root over 1 minus x square is sine inverse x. Integration of 1 by 1 plus x square is tan inverse x. Integration of 1 by x into root over x square minus 1 is sec inverse x. And these are addition, subtraction, and these are applied. These results are applied here. So this is, if we say 2x to the power 4 as fx and gx as 4x, then integration of 2x to the power 4, it is 2 is coming outside, then x integration of, so let us see this, we see this one as, so number 1 we see, so integration of 2x to the power 4 dx. So 2 is coming outside, then integration of x to the power 4 dx, and it is x to the power n, so n is 4 here, so it is 2 into, it is x to the power 4 plus 1, it is 5 divided by 5. So this is equal to, so this is 1, this is we are having 2 by 5 x to the power 5. Similarly this minus 4x, so minus is there, then 4 in, then integration of x is x square by 2, it is coming from. So this result is k is constant, so k is taken outside, k into fx, this is 2 into x to the power 4, so 2 is coming outside, this 2 is coming outside. These are same procedure. We are taking integration of 5x to the power 6 minus integration of 2x plus integration of t. So this we see integration of 3a. So integration of 3 dx for this part. So integration of 3 dx means this is equal to integration of, so 3 is coming outside, it is dx. So this dx means 1 is here. So we write this as x to the power 0. It is dx, and this is 3, it is x to the power 0 plus 1, it is 1 divided by 1, so it is thrice x. So always remember integration of dx, when you write integration of dx, it is always dx x. And if we have this say integration of dz, then for this z we need to write here z. So this is important. If this is fx, then we must write here dx. We can never integrate like this, x to the power 4 dz. This is impossible thing. It has no meaning. So always remember, if we write the function of x here, we must write here 1 dx like this. Next, this one, integration of sin x. So integration of sin x, from the formula we see integration of sin x is minus cos x, then minus 3 is taken outside, then integration of cos x, it is the formula sin x. Constant is there. Constant is constant. So in in case of this integration, we get because of this thing. See, we have explained here this one, in ddx of fx plus c, because ddx of constant is 0. So this is same. When we take derivative of fx, we get gx. Also when we take a derivative of fx plus c, we get the value gx. So that is why when we integrate this gx, we must write fx plus some constant. So that is why in case of every integration problem, we need to write one constant. This is for indefinite integrals, and for definite integral we will discuss later. Now this one, root over x. Root over x means x to the power half. So n is half here. So it is half plus 1, it is 3 by 2. It is half plus 1, it is 3 by 2. So n is half. So 2x to the power minus 3. So 2x to the power minus 3. So n is minus 3. So it is minus 3 plus 1, it is minus 2, divided by minus 3 plus 1, it is minus 2. Then e to the power x, integration of e to the power x is same, e to the power x, and we write a constant here. So for this we are getting a constant, for this we are getting a constant. So for every case we get some constants, and that is why we write a common constant here. And this is c, e to the power 2 to the power 3 log x to the base 2. So this means, so 2, this is an algebraic thing, this 2 to the power 3 log x to the base 2, and this is equal to 2 to the power log of x cube. This is some property of logarithm. So if this is equal to z, then what we have, 2 to the power z, so is equal to 2 to the power z is equal to some constant. And this means what? Z is equal to, this z is equal to log of k to the base 2. So this z is equal to log of x cube to the base 2. Z here we are having log of x cube to the base 2, and that is why we write this k is equal to x cube. So this is k. This k is 2 to the power 3 log x to the base 2, and this k is equal to x cube. So this is some deduction of logarithm. So in place of writing this, the whole thing is simplified as x cube. So integration of x cube is this. So it is by the formula. So this is explained here. As we get, if we write e to the power, we have got it, e to the power log of say x to the base e, x to the base e. So this e and this e are same, that is why we can write it as x. So similar way, so these two and these two is same, so we can write this x cube. Similarly, this e and this e are same, so we can write this as x to the power 5. Next, this is trigonometric function, trigonometric property we are applying. 1 plus cos twice x. So in trigonometry you will see this is 1 plus cos twice x is 2 cos square x. So 2 cos square x, so half is taken outside, 1 by 2 into 1 by cos square x, and 1 by cos square x is sec square x. So integration of sec square x, half is taken outside, and integration, it is the standard formula, it is tan x. 1 minus cos twice x, it is 2 sin square x. So 2 sin square x, half is taken outside, 1 by sin square x is cosec square x, and we have this formula minus half cot x plus c. This one is x to the power 5 by 4, x to the power minus 5 by 4. So for 5 by 4 it is n, so 5 by 4 plus 1, it is 5 by 4 plus 1 is 9 by 4, 5 by 4 plus 1 is 9 by 4, and this is minus 5 by 4. Minus 5 by 4 plus 1 is minus 1 by 4. This is minus 1 by 4. So these are the integration value. Then this one is, so log of, so this e and e are same. So in place of this we can write root over x. So this root over x I am writing here. This x is denominator, and we can simplify this. X to the power minus x to the power half divided by x. So root over x means root over x means x to the power half, x to the power half. So root over x by x is x to the power half minus 1. So this becomes x to the power minus half. So minus half plus 1, it is half divided by half. So it is, so x to the power half, where I am writing here root over x, and half is the denominator, so this becomes 2. Similarly, this 1 minus cos twice x, I am writing here 2 sin square x, then this 2 goes, and so it is integration of sin x, integration of sin x is minus cos x. Similarly, this one, so it is 2 cos square x, as we have got there, same, this one. This one, then this cos twice x plus 2 sin. So to these problems, you know the you should know the trigonometric results. So cos twice x plus 2 sin square x. So cos twice x is cos square x minus sin square x. Then it is cos square x plus sin square x. It is 1 now. Then 1 by sin square x is cos x square x, and it is minus cot x. And this one is the same. So cos twice x is cos square x minus sin square x. This becomes cos square x plus sin square x. It is 1. So it is 1 by cos square x. It is sec square x. Tan square x. Tan square x is, because we don't have the value for integration of tan square x. So this tan square x, but we have standard result for sec square x. So we write in place of tan square x, we write sec square x minus 1. Then minus cos x, then minus 2 to the power x. So for this, these are value, you can have the results. Integration of sec square x is tan x, integration of dx integration of 1 dx means dx, integration of dx is x, integration of cos x is sin x, and this result is a to the power x. A to the power x is a is 2 here, so it is 2 to the power x by this. Then integration by method of substitution. By method of substitution, we need to substitute some value. So integration of cos twice x, we don't have formula for integration of cos twice x, but we have the formula for integration of cos x. So this twice x we substitute as some u. So when we substitute this cos u, earlier we have explained that we cannot write cos u dx. We cannot write this. So whenever we substituted twice x for u, we must write this is dx should be written in terms of u. So first we are substituting twice x is equal to u, then 2 into ddx of x is equal to du dx, and we write it now 2 dx is equal to du. We write the numerator part, so 2 dx is equal to du. So this is 2 dx is equal to du. So in place of du we need to write in place of dx we need to write du by 2. So du by 2 is here. So this is substitution, and if we write as function, so it is like this: integration of fx dx, integration of g of phi x. So we are substituting phi x as u, so this is by substituting functions. So cos twice x, so it is fx is cos twice x, then we write this g of phi x. So cos twice x is fx, but gx gu, if we write phi x is equal to u, this twice x is equal to phi x, then we are substituting this in terms of d of phi x. So these are all by method of substitution. Integration of cos cube dx twice x, so twice x is equal to t, then 2 dx dt. So we are writing twice x in terms of t and simultaneously we need to write dx in terms of dt. So dx is half of dt, so I am substituting dx as half of dt. Half is taken outside, this is t, and this is now cos square t cos t. So we are not writing x now, we are writing t. Now this cos square x we write as 1 minus sin square x cos t. Again we are substituting sin t as z, sin t as z, so that we need this substitution only to get the standard formula that we have listed in the previous pages. So this formula these are the formula. So in this formula we need to place all this integration, then only we can have. And so sin t, whereas I am substituting sin t as z, cos t as cos t dt. So sin t is z means, so sin t, so sin t is equal to z, then ddt of sin t is equal to dz dt, and ddt of sin t is cos t. Cos t is equal to dz dt. So cos t dt is equal to dz. So in place of cos t dt we need to write dz. So integration of cos t dt, you can do it now. Integration of sin square t cos t, then it is integration of cos t, dt is here, so it is sin t, and now we write this as z. So sin t is z means sin square t is z square, then cos t dt, this is dz. So this is z, this is z, and it is a formula z cube by 3. So this is z cube by 3. After putting z cube by 3, so z we now write as sin cube t, and t again we have to replace by x. So in place of t we write twice x. So whenever we substitute to some other variable, but the result must be in terms of the original variable. So this is x, so this result answer should be in terms of x, not in terms of t, not in terms of z. So this is also trigonometric result, cos twice x, cos 8x. So we got what is the result? Do you remember? This is 2 sin a. I am applying here 2 cos a cos b is equal to cos of a plus b plus cos of a minus b. So this result we need to apply, because we don't have the formula for this integration. So it is so 2, we need 2 here, so half is here, then 2 cos a cos b. So a is twice x, b is 8x, so it is cos 10x plus cos 6x. 2 plus 8 is 10, 2 minus 8 is 6, cos of minus theta is cos theta, so it is 6. And now we can have the we can apply the formula. So cos 10x dx, so it is integration of 1 by 10 cos t dt. So 10x is t, so 10 dx, it is dt, dx is 1 by 10 dt. So it is cos t dt, cos t dt, we have the standard formula, it is sin t, so 1 by 10 sin t, and in place of t we write 10x. Similarly for cos 6x, it is 1 by 6 sin 6x. And you can now have, so after understanding this, you can directly write integration of cos, say suppose cos twice x dx, you can directly write half of sin twice x after understanding this one. So this is the result. Then sin square x, so this is also we don't have the integration for sin square x formula for. So sin square x we write as 1 minus cos twice x, so that we can apply integration of cos x, cos t dt. So half of, so after separating this, integration of 1 into dx, it is dx minus half, then integration of cos twice x. So cos twice x I am substituting, so or directly we can write integration of cos twice x is half of sin twice x, half of sin twice x. So here we write half of sin twice x, so it is equal to half of this, half of sin twice x, so 1 by 2, so it is 1 by 4. So simplify this, you will get it. Here you see integration of x to the power 4 minus 2 whole cube x cube. So we substitute this. This is algebraic function, and we know derivative of x to the power 4 will come in terms of x cube. It is 4x cube. So if we substitute x to the power 4 minus 2 as z, then dz dx will be 4x cube, or 4x cube dx is dz. So x cube dx is 1 by 4 dz. So this x cube dx we can substitute as 1 by 4 dz. So this I am writing as z, then this is z cube, and this is dz. 1 by 4 is taken outside. So this is z to the, so we can integrate. So we are getting this formula, x to the power n. So it is z to the power 3 plus 1 by 3 plus 1, and in place of z we know x to the power 4 minus 2 whole to the power 4 by 16. Number 20 we see we are substituting e to the power x plus e to the power minus x as z. Then dz dx is e to the power x, derivative is e to the power x, then e to the power minus x, ddx of e to the power minus x is what? So dz dx is ddx of e to the power x minus e to the power minus x. Then one by one I am doing. So ddx of e to the power x minus ddx of e to the power minus x. So ddx of e to the power x is e to the power x, and ddx of minus e to the power x is e to the power minus x into ddx of minus x is minus 1 by chain rule. So minus minus plus, and this becomes e to the power x plus e to the power minus x. So substituting this e to the power x plus e to the power minus x, sorry, we have done, no, this should be plus, this is plus, this is plus, this is substituting where e to the power x plus e to the power minus x I am substituting. So this is plus, this is plus, so this becomes minus, this becomes minus. So e to the power x minus e to the power minus. So dz dx is e to the power x minus e to the power minus x. So dz is e to the power x minus e to the power minus x into dx. So this is this into dx is equal to dz. So after substitution of this z, we get dz here. So integration of 1 by z formula, it is log z. So in place of z I am writing e to the power x plus e to the power minus x. So this is done with the help of method of substitution. Then this sin cube x cos cube x. So sin cube x cos cube x. So cos x, so cos cube x we write as cos square x into cos x. Then this cos square x we write 1 minus sin square x. Then this becomes function of sin x. So it is sin cube x cos x minus sin to the power 5x. After simplifying this, then we write, because ddx of sin x is cos x, so this is z, this is dz, this is z cube dz minus z to the power 5 dz, and this is standard formula now, x to the power n formula. So it is z to the power 3 plus 1 by 4, 3 plus 1 by 3 plus 1, and this is z to the power 5 plus 1 by 5 plus 1 plus constant. So z to the power 4 is sin to the power 4x by 4. So in this way we need to substitute so that we can have a standard formula for this. Then integration of tan x. Integration of tan x, no formula for this integration of tan x. That is why we need to write sin x by cos x. This sin x by cos x means if we write cos x as z, then this is minus sin x dx. So this is z, this is minus dz, this is minus log z. So log of minus 1 becomes power of this. Then 1 by cos x is sec x. So this also we can apply now as standard formula later. So integration of tan x is log of sec x. Similarly, integration of cot x, same procedure, it is log of sin x. This is also same, sec x. So sec x is written as sec x into sec x plus tan x, denominator is sec x plus tan x. So this is because sec x means sec x by 1, and we are multiplying both numerator and denominator by sec x plus tan x, and then sec x plus tan x is z, and ddx of sec x is sec x tan x, ddx of tan x is sec square x, and we get dz here. So this is dz, this is z, and integration of 1 by z, it is log z. So it is, so integration of sec x, this also you can later you can use as result. Integration of sec x is log of sec x plus tan x. This is another method. Integration of sec x, we write 1 by cos x, then cos x is cos square x minus sin cos square x by 2 minus sin square x by 2. These are all trigonometric results. This is sec square x by 2, 1 minus sin square x by 2, and this is having, we are having some results later. So this is z 1 minus z square dz. So this is one result. So this is a result 1 by a square minus x square. This result is 1 by twice a log of a plus x by a minus x. So here a is 1, x is z, this is 2 dz, 2 is taken outside, so dz by 1 minus z square, it is 1 by 2, a is 1 here, then log of 1 plus z by 1 minus z, and in place of z we write tan x by 2, this one. So in this way also you can find integration of sec x dx, it is log of tan of x by 2 plus pi by 4. These are also same. Cosec x, it is log of this. You work it out and you can understand it. Integration of cos x. So 1 by sin x, as we have written 1 by half diangles, in terms of half diangles. So this is also in terms of half diangle. It is 2 sin x by 2 cos x by 2. Then this dividing by cos square x by 2, numerator we get sec square x by 2. This is cos x by 2 cos, it is tan x by 2. So tan x by 2 is derivative is sec square x by 2 into half. So this is z, this is dz, this is z, so this is z dz, so it is log of z. So log of z means z is tan x by 2. So these are all by method of substitution. Do tan x, so tan x, derivative of tan x is sec square x, so 2 plus 3 tan x, then so ddx of 2 is 0, so 3 sec square x dx. So in place of sec square x dx we write dz by 3. Then it is similarly this 1 by log x. These are all by method of substitution. So we are putting log x is equal to z. This is 1 by x dx, this is dz. Then I is, so these are all by method of substitution. So this is cot x, so log sin x as z, then ddx of log sin x is cot x, so this is dz by z, so it is log z. E to the power twice x plus 3, so this is as z, then ddx of this is 2 e to the power x twice x dx is equal to dz, then this one is dz by 2. Then cos square this one, so cos square this, so it is 2 cos square 3x minus 5. So if we write this as theta, so 2 cos square theta is 1 plus cos twice theta, so it is 1 plus cos twice theta means 2 into 3x minus 5, so that is why it is 6x minus 10. Then integration of dx, integration of cos 6x minus 10, so 6x minus 10 is now written as z, then it is 6 dx is equal to dz. This is tan inverse x. This result we have got before. So integration of 1 by x square, it is tan inverse. So we are substituting x by a as z. So 1 by x dx is equal to dz. So this is also one result, standard result. So integration of 1 by x square plus s square is 1 by a tan inverse x by a. This is from sine inverse function. So integration of 1 by, so we are substituting x square x by a as z, 1 by a dx is equal to dz. So it is sine inverse z formula, sine inverse x by a. So this is also one standard result. Next, this is 1 by root over a square plus x square. So here substitution is somehow different. So we write x plus root over a square plus x square. This is equal to z. Then derivative of dz dx is, this is 1 and this one is, so 1 by, it is a square. So dz dx, so for this dz dx is equal to d dx of x plus root over a square plus x square. Then d dx of x is 1 plus d dx of root over a square plus x square. Now this is 1 plus, so this is by chain rule. Chain rule means first we root over function, so root over means it is 2 root over a square plus x square into d dx of, this is chain rule, a square plus x square is equal to 1 plus, so this one is twice x, d dx of a square is 0, d dx of x square is twice x, and 2 root over a square plus x square. Then 2 goes. Now we simplify this as, this is denominator is root over a square plus x square, and it is x plus root over a square plus x square. So this we write as z. Also ultimately what we get, this is equal to z by root over a square plus x square. So what we have, dz dx is z by root over a square plus x square. So dz dx is, and now we write this z, we separate the variable, so we write this as dz by z as dx by root over a square plus x square. So so initially we are given this function, so 1 by root over a square plus x square, and this we write 1 by z. In place of this we write 1 by dz dx, and this log z, and in place of z we write this one. So this is also one standard result. 1 by root over a square plus x square is equal to log of x plus root over a square plus x square. Then this is minus, same procedure. So x plus root over x square minus a square, it is z. In same way we have dz by z and this log of this. So this results, this to be noted, 1 by root over a square plus x square, 1 by root over a square minus x square, 1 by root over x square minus a square. This is for second inverse, standard formula. So this is all by method of substitution. Then this is integration by parts. This is some formula. So integration by parts, it is integration of fx cx, it is fx into gx dx. So this thing we need to apply. So integration of log x, we don't have any standard formula for this. So this log x we write 1 into log x. So 1 we consider as sum. So this is product of two function. This is the function fx is equal to 1, and this is the function gx is equal to log x. So fx is log x and gx is 1. So fx, this is log x, then integration of gx is 1 minus integration of d dx of fx, it is log x, and integration of gx, it is integration of 1 into gx. So all we are putting this formula here. Then integration of 1 is x, log x is log x kept here, minus d dx of log x is 1 by x into x. So ultimately what we get, x goes 1 here. So it is integration of 1 dx is equal to x log x minus x plus c. So what we are having, so integration of log x is x log x minus x. Similarly, integration of sine inverse x, same procedure. So we write it as 1 into sine inverse x. It is equal to sine inverse x as fx and 1 as gx. So all this by formula, this formula, applying this formula. So sine inverse x, integration of 1 dx, integration of dx, ddx of sine inverse x, it is integration of 1 is gx, and then after simplification we get this one. So it is x sine inverse x minus and x dx. Now we substitute again 1 minus x square as z, so that we have a standard formula for this. So it is dz by root over z half. So it is of the formula x to the power n formula, means what? Z to the power this is minus half, z to the power minus half, it is half minus half plus 1 is z to the power half, so it is root over z. So ultimately we get this is 1 minus x square. So this is for integration of sine inverse x, it is x sine inverse x plus root over 1 minus x square plus c. Similarly for tan inverse x we have this one. All are explained here, just you do it by step. This integration of x square minus 1, so I applying this one, x integration of x square minus s square, a is 1 here. Then integration of x log x, so log x into x dx, it is also method of, it is by product formula, integration by parts, integration of product of two functions. So when we have log x here and this is algebraic function, we need to take derivative. So log x as fx, so that we have 1 by x here and it can be cancelled out with this. It becomes function of single variable. Log function goes. And this is x square sin x, so x square is taken as fx, x square. So when there is a this is log x into x to the power n, we take log x as the function fx. But if we have sin x or e to the power twice x, e to the power x as here, then we write x square as fx. So these are by all products. This is all by product function, e to the power x into sin bx. So here you see sin x e to the power x, again we get the same functions. Sin x becomes cos x becomes sin x, e to the power x is always e to the power x. So in this case we cannot have a value without integration. So this again we are getting the same function, e to the power x sin bx, and in that case we take this to left hand side. So I we write it this as I. So I is equal to e to the power integration. So this is I. So again we are getting I here. So this we take to left hand side. So it is 1 by s 1 plus a square by b square is equal to 1 plus this one. Then I, value of I is we divide by the coefficient of I. So this is equal to e to the power ax, this one. So same for e to the power x cos bx. So I is value of I is e to the power x by a square plus b square, this one. Then integration of this is also same procedure. Again we get this integration into it. So if it is I, again we get one I here to the right hand side. Then we transfer this to left hand side, and these are all free from integration. This is also same. Then these are same. Then integration of rational function, it is by partial fraction. So for partial fraction, these are some result we have got earlier. So this is the case when this is algebraic fraction, so that we can factorize the denominator. So these are results of partial fraction. Then this is the method. Means what? We are writing this fraction as sum of some simple fraction. So this 1 by a square minus x square we are having in terms of 1 by a minus x by 1 by a plus x, so that this comes as logarithm function 1 by x. So this is the result, important result. Integration of, we have got integration of dx by x is equal to log x. Base is always e. So whenever there is some constant added to this x plus say a, it is again log of x plus a. X plus a, brackets should be always there. And if a minus x is there, integration of, if it is a minus x, this is by method of substitution. So this is a minus x is z, then this becomes minus dx here. So this is minus dz by z, because a minus x is z, so this is minus dx. 0 minus dx equal to dz. So this is dx is minus dz, so this one is then log of, so minus log of z. So minus log of z means z is a minus x, so this is equal to minus log of a minus x. So integration of a minus x, it is minus log of a minus x. Then these are all the same. So it is a linear factor. Linear factor means x is first degree, so these are all in terms of logarithm function. So is x square minus 16, 16 is x square minus a square, so this is x square minus a square. A is 4 here, same. So this one is dx by, this is second, this is second degree function. Here what we do, this is partial fraction, this is second degree, this is first degree, so it is proper fraction, and proper fraction we always write like this. Then so all are of same procedure. It is all by method of partial fraction. This is in case of when these are algebraic fractions. This is algebraic fraction. We are writing as sum of first degree. Denominators are all are of first degree. This is x cube minus 1. X cube minus 1. This is x minus. So these factors are x minus 1. This is first degree. This is second degree. So our this decomposition is like this. So we get a as 1 by 3, b as minus 1 by 3. So our result is 1 by x cube minus 1 is this one. So say this you can have it understand. So this part, this will come as logarithm, then this one x square plus x plus 1, then derivative of, if we substitute this as z, then this is twice x plus 1 is dz. So x plus 2 is here, this is, we need twice x plus 1, so we make this twice x plus 4, so and we divide by 2. So 1 by 3 becomes 1 by 6. This is twice x plus 4. So this 4, because we need only 1, so this 4 we are writing again. This is this 4. We are breaking it again. So it is 1 by 6. This is twice x plus 1. 3 is here again. So we write again 3 by x square plus x plus 1. So this is 3 by x square plus x plus 1. Then 3 this 3 goes with this is minus half 1 by, now this we are writing as s square plus x square, sum of square. So x square plus x plus 1, so x square plus x plus, so x square plus x plus 1 we can write as x square plus 2 into x into half plus half square minus half square plus 1. So it is x plus half whole square minus 1 by 4, it is 3 by 4. So this is x z square plus s square. So we are substituting this as z. So tan inverse of, so this is in, so this one is integration of, this is half integration of, so this we write as z square plus 3 by 4 means root 3 by 2 whole square. Then this z, so because it's first degree coefficient 1, we can directly write as dz. So what is of this form? It is of the form integration of dx by x square plus a square formula. So it is in terms of tan inverse x. So 1 by a tan inverse of x by a, this formula. So it is 1 by a is root 3 by 2. So it is 1 by this, then tan inverse of z is x plus half divided by a. So in this way we can do this type of fractions. This is not proper, so we write it as x cube plus 1 as x cube plus 1 minus 1. Then this becomes 1 by x cube minus 1 minus 1 by x cube plus 1. Again this is same. So this is x minus, this is factorized as x minus 1 into x, this one, and here we factorize this as x plus 1 into x square minus x plus 1. So these are the procedure of doing these problems. This is also partial fraction. We are doing this. All are from method of partial fraction that you got in the first semester algebra course. This sin twice x minus sin x minus sin twice x. What we do it? Sin square x, sin x we are multiplying by this. So this is sin x, this is sin square x. This is 2 sin x cos x. So 2 sin x cos x is 2 sin square x cos x. So sin square x taken outside. Then it is sin square x is 1 minus cos square x. It is 1 minus 2 cos x. Now we write it as this cos x as u, then this becomes du, again by method of partial fraction, this one. So in this way we are doing this integration. So 1 by sin x minus sin twice x, by replacing this like this u, we can integrate it by is 1 minus cos x by this. So these are practice examples. These are some practice examples. Can practice it. These are all from trigonometric functions. Trigonometric functions, these are 1 by root over 6x minus 1. So 6x minus 1 is z, then 6 dx. So all you can do by method of substitution. Cos x, this one, then sin x cos square x, it is cosec x sec square x. So sec square x is 1 plus tan square x. Again we are simplifying this. Cosec x we can have it, then this becomes sec x tan x, all by standard formula. This tan cube x, then tan square x becomes sec square. So then again we get tan x sec square x. This is sec x tan x. This is tan x. This is ddx of tan x. Then this is integration of tan x is log of sec x, etc. This is x sine. This is by product formula. This product formula all are. This is also the product formula. Sine of root over x. How we are doing it? See, root over x we are substituting. Then we get another this root over x here. Next is u 1 by 2 root x. So du is 2 root x dx du. Then sine root over x dx sine u. This is 2u du, u sine u du. Again by method of, this is product formula, fx into gx formula, integration by parts. These are all integration by parts. These are integration by parts. Is it integration by parts? All are. This is substitution. X cube. It is we are writing x square. Then x square. After this substitution, this is integration by parts. So these are all are examples of this by deduction. So every problem we need to put in some by all this method we need to write this as standard formula. So this after deduction of this we get this standard formula 1 by root over 1 plus x square. This formula we are applying here. Similarly this one again, this one is standard formula, integration by parts. So this we see in the power x plus 1 minus 1 by x plus 1 whole square. So this one is also this is expressed as sum of square, and it is sum of square is a square plus x square, and we are having formula for this. This is also sum of square. This is sum of square. All are sum of square. This is also is root over a square plus x square formula. This one we see this is in terms of sine inverse after deduction. Then so these are the worked out problems. We can all things we need to know the standard formula. Then we need to make some deductions so that we have this as we can put it into some formula and we can apply the results. So this is integration of cot cube x. After deduction we get this formula. again cot x cosec square x after substitution. So this cot x is log of sin x, then this after substitution cot x has z, it is dz. So again it is z dz formula. So all are like this. This is again by method of partial fraction. These things we can deduce as in terms of this first degree values, first degree denominator. This is, so these are the examples. After working out all this, you can have some so all are like this. So that's all for integration.